Auzubillahiminash-shaytanir-rajeem. Bismillahir-rahmanir-rahim. Dear students, me, Muhammad Asif Qureshi, Assistant Professor of Chemistry, Government Boys Degree College, Kasmabad, Hyderabad, welcome you all in the today's lecture, which is the last one from chapter number 8 of Inter-Syllabus Chemistry, Alkyl Halides. Yesterday was the part 1 of lecture number 5, in which we started the Grignard's reagents and their synthetic applications. Today is the part 2 of lecture number 5, in which we have to discuss the remaining 4 synthetic applications, because we did the first 5 synthetic applications of Grignard's reagents yesterday, and in those 5 reactions we got alkanes as the main product. Now today I am continuing from the 6th reaction of alkyl magnesium halides, Grignard's reagent, and the 6th one is the reaction with carbon dioxide CO2. And whenever Grignard reagents will be reacted with carbon dioxide, the product obtained will be a carboxylic acid. Look at the board, try to understand the things. This is the general representation of Grignard reagents, alkyl magnesium halide. When it is reacted with CO2, carbon dioxide, an intermediate product will be formed in such a way. This double bonded electron pair will be shifted to the oxygen atom, making it negatively charged, while the carbon atom, by losing this electron, will acquire positive charge. As a result, this positively charged carbon will be attached to this negatively charged carbon chain, alkyl radical, while this negatively charged oxygen will be added to this magnesium atom, which is positively charged. As a result, an intermediate product will be obtained by the addition of these 2 molecules. Further, this intermediate product will be reacted with water in the presence of dilute hydrochloric acid. This hydrogen atom, partially positive hydrogen atom, will take this part of the molecule with it, as a result of which we will get RC double bond OH, the carboxylic acid, while the OH group will be added to MgX, making it MgOHX, magnesium hydroxy halide. Now dear students, if I take methyl group as the alkyl radical, and in place of this X I have put chlorine atom here, the compound which I have taken here is methyl magnesium chloride. When methyl magnesium chloride is reacted with carbon dioxide CO2, the same way this double bonded electron pair will be shifted to the oxygen atom, making it negative, while the carbon becomes positive. The positively charged carbon will be attached to this methyl group, while this negatively charged oxygen will be added to the magnesium atom. This will be the intermediate product obtained by the addition of these 2 molecules. When this intermediate product will be reacted with water, the H of water will take this negative part of the molecule, making acetic acid or ethanoic acid as the main product, while the OH group of water will be added to this MgCl, making it magnesium hydroxy chloride. Now here one thing I must tell you, whatever type of carboxylic acid you have to make, you have to take that alkyl radical here. If you want to make propionic acid as the main product, you have to make this one as the ethyl group. If you want to make butyric acid as the product, you have to take propyl group here. If you want to make valeric acid or pentanoic acid there, you have to take butyl group here. So any type of carboxylic acid you want to make as a product, you have to take such type of alkyl radical here. So this was the 6th synthetic property of alkyl magnesium halides, which was the reaction with CO2, and product obtained was carboxylic acid. Coming to the next reaction, reaction number 7, which is with formaldehyde. When Grignard's reagent will be reacted with formaldehyde, the product obtained will be a primary alcohol. Now this is the general representation of the reaction, RMgX, alkyl magnesium halide, plus this is the formaldehyde, CH2 double bond O, this is formaldehyde. an intermediate product will be obtained, which will be then reacted with water. In the presence of dilute HCl, we will have a primary alcohol along with magnesium hydroxyhalide. Now this is the reaction which we want to make understand in our minds. Now this is methyl magnesium iodide. When it is reacted with formaldehyde, this double bonded electron pair will be shifted to the oxygen due to its high electronegativity. Oxygen atom becomes negatively charged. Carbon will acquire positive charge. This positively charged carbon will be added to the methyl group, while this negatively charged oxygen will be added to the magnesium atom. As a result, an intermediate product will be obtained, which is then reacted with water immediately. In the presence of dilute HCl, the H of water will be added to the negative part of the molecule, making it CH3CH2OH ethyl alcohol or ethanol, while the OH group will be added to the MgCl, making it methyl magnesium hydroxychloride. It will not be chloride, rather it will be iodide, because we have taken iodine here, so it will be iodide. Methyl magnesium iodide we have taken there, so the product obtained will be magnesium hydroxy iodide rather. This is the 7th reaction of Grignard's reagent, in which we got primary alcohol, ethyl alcohol, as the main product. Moving ahead, the 8th synthetic application of Grignard's reagent is the reaction with any other aldehyde except formaldehyde. When I say any other aldehyde except formaldehyde, I must mean it that it may be either acetaldehyde, propionaldehyde, butyraldehyde, whatever. So whenever Grignard's reagents are reacted with any other aldehyde except formaldehyde, mind you all, the product obtained will be a secondary alcohol always. This is the general representation of the reaction: RMgX, alkyl magnesium halide, plus RCH double bond O. This is the general representation of any other aldehyde except formaldehyde, depending upon the nature of the carbon chain to be used here. An intermediate product will be obtained. When reacted with water, this intermediate product will give you secondary alcohol along with magnesium hydroxyhalide. Now coming to the example, proper example, I have taken here methyl magnesium bromide, and when this methyl magnesium bromide is being reacted with acetaldehyde, the next higher aldehyde to the formaldehyde, acetaldehyde, this double bonded electron pair will be shifted to the oxygen atom, making it negatively charged. Carbon will acquire positive charge. This positively charged carbon will be added to the methyl group, while this negatively charged oxygen will be added to the magnesium atom. By summing up the two molecules, we will have CH3, then this CH, then this methyl group attached to the carbon is written over here, then oxygen was connected with magnesium is being connected with bromine. This intermediate product will be immediately reacted with water. The hydrogen atom of water will take this part of the molecule. As a result, you will have secondary propyl alcohol or isopropyl alcohol, while the OH group will be attached to the MgBr, making it magnesium hydroxy bromide. This is the 8th property, 8th synthetic application, in which we reacted alkyl magnesium halide with any other aldehyde and we got secondary alcohol. Moving ahead, this is the 9th synthetic application of Grignard's reagent, which is the reaction with ketone, and the product obtained will be a tertiary alcohol. This is general representation of Grignard's reagent, RMgX, alkyl magnesium halide. This is the general representation of a ketone molecule, RCR double bond O. This double bonded electron pair will be shifted to the oxygen atom, making it negatively charged. Carbon becomes positively charged. This positively charged carbon will be attached to this alkyl radical, while negatively charged oxygen will be attached to this magnesium atom. As a result, the intermediate product will be obtained, which is then reacted with water to give tertiary alcohol here. along with magnesium hydroxyhalide. Now looking at the example, I have taken methyl magnesium chloride, and this methyl magnesium chloride I have reacted it with acetone or dimethyl ketone. Acetone is the basic and the first member of ketone family. So this electron pair shifts to the oxygen atom, making it negatively charged. Carbon acquires positive charge. This carbon will be bonded to the methyl group. As a result of that, this methyl group will be attached to the carbon. This intermediate product will be obtained, and oxygen atom will be attached to the magnesium. When reacted with water, this intermediate product will be converted into tertiary butyl alcohol, because this partially positive H of water will take this negative part of the molecule, making the product as the tertiary butyl alcohol, while OH group, hydroxy group will be attached to the MgCl, making it magnesium hydroxychloride. So dear students, yesterday we started this topic, Grignard's reagents and their synthetic applications. We discussed first 5 synthetic applications of Grignard's reagents yesterday, which were the reaction with water, reaction with ammonia, reaction with amine, reaction with alcohol, reaction with alkyl halide, and in all those 5 applications we got alkane as the main product. Today we started with the 6th reaction. 6th was the reaction with carbon dioxide. Product obtained was carboxylic acid. In 7th reaction we treated Grignard reagent with formaldehyde. We got a primary alcohol. In 8th reaction we got reacted the alkyl magnesium halide with any other aldehyde except formaldehyde. The product obtained was a secondary alcohol. And now the 9th reaction, last, was reaction with ketone, and product obtained is a tertiary alcohol. So in this way, dear students, we have finished chapter number 8, alkyl halides. In this series of lectures, we started alkyl halides from the introduction, nomenclature, methods of preparation, classification, and slowly, gradually we have ended the chapter today. So inshallah, in the upcoming lecture with any other topic from intermediate chemistry syllabus, we will be meeting together. Till then, Khuda Hafiz. Assalamu alaikum wa rahmatullahi wa barakatuh.